Hi guys, Mr. Johnny here. Again, this video ain't gonna be a project. This video is gonna be another repair. Now, before I go into it, I'm gonna put this again, kind of a disclaimer, really. These videos are not how-to videos. I do not pretend to be the master here, the know-it-all, you know, and just. These videos are intended to be somewhat informational, but mostly just to document me mucking around with some stuff that I repair. If you learn something in the process, great, but do not treat these videos as how-tos. I do not encourage you in any way to go and try fixing a TV if you don't know anything about it. You need to learn something beforehand. That's just the way it is. But here another one of these. This time it's LG. You can see there. Or you can't. Oh, come on. There's enough light for it. Focus, you. Finally, it didn't took a year. I wasn't gonna make a video about it, but I changed my mind when I took the cover off, because I saw something which is rather unique actually, because I've never seen a TV set with such a problem, where that part literally fried itself. That's, I think, what happened. The part fried itself, although it may be something else that fried it. Anyway, I even cobbled a little light there, so you can see better. Night and day. Oh boy. Yeah. And if I'm gonna take the cover off, that's painful. Have in mind that I do this 11 p.m. You know, you can see the indents. Why? That's why I said that it was painful. But here, yeah, that desk lamp really makes a world of difference. Make sure it ain't gonna fall on my head. So, first thing first, you see that this set is not incredibly dusty. You can see not much dust, typical for this stuff, but it's quite hairy. All right. So, yep, you can see a nice amount of cobwebs there. And look at that. Isn't it beautiful or what? That's one of the most beautiful dust bunny conglomerates I've seen so far. As of today. Look at that. Thing of beauty. Joy forever. Some of you may be cringing, like, right now, like, what the hell do you need to mug with this CRT TV for? It's so dusty and stuff like that. Well, if you say that, you did not. I'm gonna say you haven't seen what Shango 066 has to repair, to resurrect, that is. Shango 066 is the king when it comes to filthy televisions. If you want to see somebody restore, bring back to life some old televisions, much older than this, antique stuff, retro, you go to his channel. I'll leave a link in the description. Enough mumble. Visual inspection. Besides that beautiful dust bunny conglomerates and stuff, just take a look at the board. There is no visible bulged capacitors at all, and there is no fried parts. You might think so until I'm gonna try to set it up. Until you look into the power supply and have a look at that coil right there. A bit further inside from that blue capacitor. Don't you think it looks a little bit, you know, little bit unhealthy? The funny thing is that with that coil being so nuked, the fuse, which you can see right there, is okay. And there is no short across the line, because if there was, the fuse would blow itself the moment you turn it on, but it does not. The switch feels kind of finicky, but it still works, I think. So I'm gonna pull the chassis out, but before I do that, I'm gonna go and give it a clean, because I do not want to upset this dust bunny population in here, because they're gonna fly. Dust bunnies are not the usual bunnies. These bunnies can fly and do that very well. The chassis cleaned up nicely, as you can see right there. Not bad at all. This set, by the way, the client said it's never been serviced before, and they own this set for like 20 years or so, maybe more. I don't know about more than 20 years, but it can be the 20 years. And they said it never developed problems before, which kinda, actually, I do kinda believe that, because if the set would have developed a problem, they would have sent this television to a local repairman, and when he will repair this set, I would see signs of that repair very easily with naked eye. Oops, demonetized. Anyway, and the board looks fine. There is no flux residue at all. I mean, like, there is a little bit of that, but it's factory. Bang. How about that? What the hell is that about? Bang. Alright, whatever. Okay, so what are we interested in? The choke, which has developed a very strange problem. Namely, it burnt itself. So it seems. You can see a nice crack there. Oops. And yeah, just take a look at it winding. It is completely roasted. Man, this thing got hot. I do not know, just plain and simple, what the hell can happen to it that it will do that. Because, well, you might say, surge on the line. Good idea, good theory, but the line comes in here, goes through the fuse, then there is MOV, metal oxide varistor. So that will eat up that pulse, it will conduct and blow the fuse. If the pulse is big enough and long enough, the fuse is okay. Alright? Then there goes a switch, X-class capacitor, and a common mode choke. If the capacitor would have shorted, although X-class capacitors are not likely to short at all, they are rated X-class for a reason, because they're kind of self-healing, they do not short. If they do fail, they fail open circuit, usually. And yeah, I just don't know what the hell happened to this coil. It is ridiculous. Again, I do not understand what the hell can happen to it that it will do that. It's ridiculous. So the proper thing to do now will be just to take a ohmmeter and ohm it out, see if there is continuity in both coils, which I doubt there is, otherwise the set would have started just fine. You can bypass this thing. and it will work. It will just not pass EMC anymore. Okay, let's ohm it out. Well, that's not right. It should beep. It shows some kind of 270 millivolts or worse voltage drop. And another coil is plain and simple. Plain and simple, it is nuked. Look at that. It is just open. I have a hunch what can do that to that thing. That is faulty PTC, which is responsible for feeding the degauss coil, which is this part right there. This PTC had 3 legs. Oh, it's actually the self-heating one. It has only 2 legs. Let me focus here. You can see this one and this one. So here's your mains. You can see it comes here. Eventually it makes its way to the common mode choke right there. Say live and neutral on the other side. One side goes straight to the degauss coil, other side goes to that PTC, and the other side of the PTC is to the common mode choke. So that is in series with the coil. If it is short, it can very well do that. It will slowly but steadily draw a surreal amount of current, which will cause the winding of that common mode choke to be nasty. One thing though, the thing is that the degauss coil did not look nuked. And why it would be nuked? Well, because the degauss coil is wound with wire, which is not much different in gauge. I mean, it's not much different cross-section wise to the wire used to wind this common mode choke, so it's pretty much same wire. So if this fried, so would do that. The same. Oh boy, what the hell is going on? The degauss coil will do the same. Ooh, finally. I just don't like to make these videos, you know. Yikes. That PTC sounds a little bit nasty, if you ask me. 10 ohms. That seems okay-ish. Because it's a PTC, when it's cold it has low resistance. As the current flows through it, it will heat up. That's why I said that it is self-heating type. Because there is another type which has 3 pins, and there are 2 PTCs inside. One PTC is used plain just as a heater, pretty much. And the other PTC is a PTC which is in series with the coil. And the other PTC, which is the heater, is directly across the line on the output of the common mode choke. Here it's not like that, but in some sets it is. Let me desolder that PTC because it has only 2 legs, and we will take a look inside of it. We will see for visual damage there. Okay, here's the part. See, it has 2 legs. There will be 1 tablet inside. Oh, tablet, I don't know how to... It's not a tablet really, it's more like a coin. Coin of... oh boy. It happens. PTC material, you can see that there. Not to worry, this case glues together very nicely, because the cases on these devices are just fragile as fragile as it gets. It's normal. See? As I told you. The PTC looks mighty fine, if you ask me. We can actually test it on the power supply, so let me do that. The part is connected, you can see. I'm gonna put it there. 5 volts, because you saw that resistance is about 10 ohms, so half an amp should flow. Current limit to the maximum. And if it's working fine, we will see half an amp, then it should go down. It doesn't. Okay, let's heat it up a bit more. Let's pass about an amp through it. Oh, there we go, see? That's how that part works. And eventually it will reach an equilibrium. Its resistance will rise so high that the amount of current that will flow through it will keep it at a constant temperature, sort of. See, it's about 1 watt right now. It started at 10. So basically it's just a 1 watt resistor. Once the degaussing coil has done its business. Yeah, do not feel bad for this PTC that I broke its case apart. It's worth it. It really is, because if that PTC would have been... sometimes they go bad. What do they do when they go bad? See the metal wipers there inside. They contact pretty much a metal plate on the one side and on the other side. And between those plates is a PTC material which has positive temperature coefficient. That's what actually degrades, and sometimes when it does that, it deforms, it cracks, it might do some weird stuff, and when it does that, the contact of this wiper to that plate on the disc, it will get bad, and the arcing will take place, and it will eat away that surface, and it will arc inside, and it will get hot, and it will be a fire hazard. So that's not good at all. Hence why I said that it's not a big deal that I broke it apart again. Cyanoacrylate super glue does an incredible job at gluing this plastic together. So don't feel bad about it. So what I'm gonna do now, alright, let's test the resistor. It is a 1 ohm. The resistance of the probes is about 2 and something, like 2 ohms, let's say. We're not asking for we do not want the precision here. That's fine, 1 ohm. Okay, diode test. And how to test the bridge? Well, you have 4 pins, so you can test each and every diode in the bridge. To do that, make sure your bulk capacitor is discharged before you do that. Mine is, because the common mode choke was open. To do that, you put the red probe on the negative output of the bridge, and you put the black probe on one of the AC inputs. We see one diode there, another input. We see one diode there. You can reverse check it, but I see that from the voltage drop that the diodes are fine. For the other 2 diodes, you need to put the black probe on the positive output, and the same red probe on the one input, and then on the other one. The diodes are fine, which leaves me thinking, which is very, very strange. Yeah, the bridge rectifier seems to be hunky-dory. The question is now, What the hell caused this common mode choke to incinerate itself? That's so strange. Look at that. It is nuked. And the wire that it is wound with is not a wimpy little wire. Looks like a 0.5 millimeter in diameter, so that's a decent wire for the current draw there is on the primary side, but it still managed to... Oh, what the hell? Well, if you take a look at the X-class capacitor carefully, you see that it is deformed there. So let me desolder it and show you better. Okay, the capacitor is right here. Sorry for shaking, as the phone is a bit unstable. This side is fine, but that side has is melted, and that side faced the common mode choke here. I still do not. I mean, for it to do that, something on this side of it, so on this side, supposed to be pulling current, supposed to be shorted or overloaded and or whatever. It is so strange. I don't know. Okay, one thing I'm gonna do is I'm gonna check that small capacitor there, if it's fine or not. I'm gonna replace it if it's not fine, ESR wise, and then I'm gonna go and proceed to turning it on. You can see the common mode choke has been bypassed, like that. No need to desolder it actually, just gonna do it quick and dirty way. Guess what, guys? I went to check that capacitor that I talked about, which is... Oh, where the hell is it? Here it is. That capacitor. ESR meter right there. As you can see it without the glare, it would be nice. Although you do not need to read the actual text numbers there. You just see the needle move. And I lost that capacitor again. Beautiful. For crying out loud. Here I'm gonna go and you can see touch the probes together pretty much, which demonstrates that ESR meter is turned on indeed. But if I'm gonna touch the other side of the capacitor, let the needle settle and retouch it, and it barely moves. And that is just plain inappropriate for a 100 microfarad 35 volt capacitor. The thing walked and did not blow a fuse, which is good, because that means that this switching device, which is, you can see, has multiple pins, so it's not a simple transistor. And what that means, it is expensive to replace if you can find it. Yeah, so that's why I said. And trust me, I did not measure this beforehand. I told you as I went along, and see, you do not need... Yes, it's a good idea to replace capacitor on the secondary side, you know, but much more damage will be done to the circuitry if the capacitor on the primary is bad. Regardless, is it using a simple transistor or a hybrid kind of IC anyway. It does more damage when it has an IC, because that is a power supply decoupling for the actual integrated circuit that controls the switching device, which is inside of the same package. Oh, I hope that makes sense. I'm gonna replace the capacitor, and I'm pretty damn, you know, sure that it will work flawlessly. I do not want to run it with this capacitor because you see, what it has done to a 0.5 millimeter wire. I don't know how in the world this fuse did not blow when the 0.5 millimeter wire went like that. It's beyond me. It really is beyond me.